Hi, my name is Ji Huan and I'm working at Naver. This work was conducted through joint research between Hee-Soo Kim, Young Junyu, and Jungwoo Ha, who are members of Naver AI Labs, and Professor Jongmin Choi at GIST. This presentation is presented by Naver Clova dubbing model, called Matthew. We propose to diversify the visual appearances of samples in episodic memory for realistic continual learning setup and name it as rainbow memory. Continual learning has been recently re-highlighted as a realistic learning scenario. However, the disjoint configuration of classes across the task is rather artificial, and, very recently, the blurry task configuration has been proposed for a more realistic continual learning setup. The figure is the graph for item search frequency by time in our e-commerce service, and it shows blurry is more realistic than disjoint configuration. There are some scenario setups for continual learning. The disjoint setup consists of tasks which do not share the classes, whereas blurry can share the classes across the tasks. In addition, online and offline continual learning is whether it allows the temporary buffer for storing incoming samples of a current task or not during model training, respectively. We address arguably the most practical setup, which is the blurry and online continual learning. Most of the literature addresses the disjoint offline setup, and there are very few works on blurry and online setup. We are the first to conduct extensive experimental validations on blurry online setup. We approach continual learning by diversifying the visual appearance of the samples. In the previous tasks, we argued that the exemplars which are selected to be stored in the memory should be not only representative of their corresponding class, but also discriminative to the other classes. Specifically, we choose the samples that are near the classification boundary are the most discriminative, and the samples that are close to the center of the distribution are the most representative. As a measure for discriminability and representativity, we compute the uncertainty of a sample by the variance of model outputs of perturbed samples, by various transformation methods for data augmentation, and select data from the lowest uncertainty to the highest with a uniform interval for each class. To further enhance the diversity of exemplars from the memory, we employ data augmentation. We found that the efficacy of the data augmentations has not been well investigated in the literature. The data augmentations diversify a given set of samples by image level or feature level perturbations, which correspond to the philosophy of updating memory by securing the diversity. We considered various perturbation types, including simple single image-based data augmentation, perturbing the original input image, and mixed label data augmentation, which integrates multiple images, and automated data augmentations. In extensive empirical validation, we show that the proposed method consistently outperforms prior works in various data sets, and the gain becomes larger when the number of classes increases, which is more challenging. Even though blurry continual learning is the main task of our interests, we also investigate the performance of our proposed method on disjoint continual learning setup and in various blurry levels. Our method outperforms various online and blurry including disjoint setups. Although the proposed method is designed for blurry and online setup, it comparably performs to the other methods in offline setup. In sum, we address the continual learning by diversifying the visual appearance of the sample by a memory management scheme with uncertainty via invariance. In addition, we also show data augmentation significantly improves performance in online, blurry, continual learning. Please visit our GitHub repository for the codes, data, and detailed experiment setups. Please visit our poster for more experiments and analysis. Thank you.